Okay.
Hello, Abby and Annabella. We did a review problem and we handed back our quizzes, the big quizzes on Mod 10, which was basically periodic motion, the spring, and the pendulum. So I have yours tucked away, so when you come back I will get it to you. Good scores across the board, A's and B's, so you did me proud. All right, we are just picking up. If you would get your comp books ready, we'll look at just a review on waves. And we had a long, kind of odd combination of words just to describe a wave. It was hardly recognizable. It had words like propagation and so forth in it. Can you read to me that definition for wave when you find it? Brendan, do you have it?
Yeah.
Would you read it, please?
A disturbance that propagates in a medium.
All right. Notice it says in a medium. So there has to be stuff to make a wave. Like the slinky had this metal stuff that it waved through. When I speak to you, when I yell at you, the medium is air molecules. So there has to be a medium. If I sucked out all the air from this room, could I still yell at you? I could not. In fact, I have to get the, have anyone seen it over in Miss Grace's room?
Yeah.
There's a bell jar that we can actually pump the air out of. Yeah, we'll have to do that. We don't meet tomorrow, right? Wednesday. So we'll have to bring that over. She's saving it for us. So if we can pump the air out of that bell jar and there's a bell ringing in it, we should hear the sound disappear when we pull out all the air. So there must be stuff, a medium, for there to be a wave of any kind. So then we graduated to two kinds of waves. What were the two kinds of waves, Jonathan? There's one that went up and down like this, and there was one that did the clumping. What were those two kinds?
I don't think I have
Okay, well, add it now. Aaron, what are the two kinds?
Transverse and longitudinal.
All right, transverse waves went up and down like this, and longitudinal waves, remember we did with the slinky, they kind of went in little clumps that traveled down the medium. So then we decided that we needed a formula. We were going into formula withdrawal, so I have trouble remembering this number, so I will give it to you on the board when we have our big quiz on this material. So what are we looking for here? Alex, what's the V and what's the T?
V is velocity, T is time.
All right, T is
Temperature.
right, temperature, and what scale?
Sound and air. That one is Celsius.
Right, remember it doesn't work with Fahrenheit, it has to be in Celsius. And this is the velocity of sound in air. So, you got the velocity part, but this formula only is for sound in the air, and it's affected by the temperature. So you get different velocities depending on the temperature. So we messed with that for a while, and then we end it with frequency is velocity divided by this creature. Morgan, what's this stand for?
Wavelength.
Wavelength. So frequency is the velocity divided by the wavelength. Could you remind me, Molly, what was the unit for frequency?
Hertz.
Hertz, right. It hurts to say hertz. It hurts to forget hertz, so don't forget. All right, let me add, before we go on to our next major topic, we'll do one more example of using this formula, and then, well, I'll do that first. And then I have one more little bit of information to tag onto this, and then we'll change gears. All right, let's pull out our calculators if you haven't already got them out. And we'll do one more example. We had one example, I'm sure. Maybe we even had two. If I already did this one, just let me know. I don't think so. Suppose we have a sound wave, and write down this example. And the frequency of the sound wave is 501 hertz. let's say that the wavelength of this particular sound wave is 0.697 meters. And I want you to find the air temperature. So this is no new information. It's sort of gathering where we were last Thursday before Hershey Park. Fun day, wasn't it?
Yes.
Beautiful day. Let's go ahead and pull out this formula and this one. We're going to need both to find the temperature. All right, I'm going to grab the one with temperature in it, and if I hit a dead end, which I probably will, I'll go over here and fill in the missing parts. So velocity is 331.5 plus 0.606 t, and it looks like I'm at a dead end already because I'm looking for temperature, but I don't know velocity. Where do I go to calculate velocity? We step over here in frequency land, because in this formula we know frequency is 501. We don't know velocity, but we do know lambda. So someone help me with this. Jonathan, can you tap away on that? Whose turn was it? Hannah? What is, when you tap out velocity, could you tell us what it becomes?
I got 349.
Anyone confirm that yet?
Yeah, that's what I got.
349, so that's going to go in next door for velocity. So we're going to put in a 349. And remember, there's always some students that add these two numbers. That's a no-no because this has a t hooked to it. So you cannot add those two numbers. You move this over by subtraction and then you divide. Anyone all the way through for temperature? I think I do have the answer.
I got 29.2.
All right,
I got 29.
29. I got 30.
I got
so-
31.
Wow, we have.
Because I ran up to
It's-
29. I ran up to 350.
It's probably rounding. Okay. So I have something around 30 degrees. With 2 sig figs, I would write it 3.0 times 10 degrees. So I'll take all of those answers. All right, that's where we were last time we were together. So, any questions about that? One thing I wanted to mention to you is we were talking about velocity of sound, and that's different depending on what the temperature is. This one turned out to be about 349. A lot of our problems, velocity is 345 meters per second for sound. Now look back in your notes, or did you remember already? What's the velocity of light? We mentioned it already.
It's 3.0 times 10 to the 8th.
3.0 times 10 to the 8th meters per second. So that's 300,000 meters in a second. That's very fast. So I just want to give you a frame of reference, and if you would write this down, this is a typical velocity for sound. This is the velocity for light. I would like to mention about, kind of give you a reference frame on this. So, if you were in a car and you're going around the earth and you're going at 60 miles per hour in a car, which is pretty typical, guess how long it would take you to go around the girth of the earth girth, the fattest part of the earth. So, at 60 miles per hour, which is something we would drive on a freeway or a highway, you could drive around the earth in 17 days. That's, non-stop. Of course, we wouldn't be doing that, but just if we didn't stop.
I need to pause it.
Okay, go ahead.